Okay, so Unit 12, questions 29 to 33. So first of all, the first couple of paragraphs, if you've done these kinds of problems before, you would probably not read them. You'd probably not read those. You'd probably just go for the questions because the exam is long, it's difficult to finish on time, and you want to be as efficient as possible. If you're learning about redox potentials for the first time in your life during the exam, then it's better off that you choose some other questions, because then you'll be more efficient. But hopefully you would have prepared. That's why you're here today. So, so usually you would skip that because it's just reiterating information that you should know, which is, some basic ideas of electrochemistry. First of all, electrochemistry is called electrochemistry. The electro, it refers to the fact that there are electrons. And so you look at the table, half reaction table, and you see that there are electrons that are being gained in these chemicals. So basically, electrochemistry looks at how electrons can be given away from chemicals, electrochemical. So electrons can be given away from chemicals and electrons can be received by chemicals. And in order to determine whether or not a chemical can receive electrons or give electrons, you have these reduction potential tables. So these tables that tell you about the potential ability, okay? But in science, potential is measured in volts. But even just as an English word, it lets you have a sense of the potential ability of one chemical to give an electron compared to another one. So then you would be able to determine if you have two chemicals together, which one is more likely to give and which one is more likely to receive. So how do we know? We know based on the E0 value. So the E0 value gives us the potential, and the idea that you have to have clear in your mind is that the most positive E0 value is the reaction that will be spontaneous as written. So it will be spontaneous as written when you have the most positive E0 value. So that's the key idea. So now in terms of what is reduction and oxidation, you could, if you know it, if you have your own way of knowing it, fine, perfect. I know some people use Leo, the cat goes grr or something, but this one, in my opinion, is the best mnemonic to remember. And that is Leo is a jerk, misspelled, of course. And so Leo is loss, electrons, oxidation is anode, gain, electrons, reduction is the cathode. Even without them telling us that this is a reduction potential table, we would be able to know that this is reduction potential because each one of those half reactions are written in a way that there's a gain of electrons. You see the first reaction is chlorine gas gaining electrons. So in the mnemonic that I put there, gain electron is reduction. So we know that all these reactions are being written as reductions, as gaining of electrons. And you see the E0 values, that those would occur spontaneously as written if they are the most positive one in the reaction. And you see a negative one, the zinc reaction, which is not going to occur spontaneously as written, as compared to, for example, the reactions above it. And you see hydrogen, which is the standard cell, which is determined to be pretty much arbitrarily at 0, so that all the other chemicals can be compared to it. And of course, potential, as I said before, is measured in volts. And just one other thing, which is just a play of words, and I've said before that ACER loves opposites. So it's very important that you know what an oxidizing agent and a reducing agent is. An oxidizing agent, and it just makes sense in terms of the English, that an oxidizing agent is something that will oxidize something else. It's an agent to oxidize, so it's an oxidizing agent. But the trickery in this, which ACER loves to test because it's an opposite idea, is that the oxidizing agent is itself reduced. That's how it oxidizes something else, is that the oxidizing agent is reduced, the reducing agent is oxidized. So just some expressions you should have in your mind when you're doing electrochemistry. Okay, so for question 29, does anybody have an answer for 29? So which takes place if Br2 is added to a solution that contains chloride and iodide ions? So Br2. So if we look at the Br2 reaction, Br2 as written, we have an E0 value of plus 1.07. Okay, so we have plus 1.07 as written. Now, if we have a solution of chloride ions, it doesn't mean that the E0 value is plus 1.36. It means the opposite. Because we have the chloride, which is on the right side of the equation, it means the reaction would go from chloride to Cl2. So that means that with chloride ions, we have minus 1.36. Well, that's not going to work out, is it? Because if we have minus 1.36 and plus 1.07 together, they would make minus something, minus about 0.3. Okay, so we end up with a negative number, which means that that reaction cannot occur. It would be the reverse of that reaction that might be able to occur spontaneously. Now, let's look at iodine. Now, if we have I minus, which is the opposite reaction of the reaction in the table, it's a reaction where electrons will end up being given off, then we end up with minus 0.554. Now, if we have plus 1, if we have plus 1.07 and minus 0.54, if we have these two reactions occurring together, then we end up with a final. So we would end up with a final of plus 1.07 minus 0.54. So that would be plus 0.53. Now, I also want you to understand why these are called half reactions. So as much as I don't want to write this out, I just want to be very clear of what that whole thing about iodine is. Okay, so the reaction of iodine is 2I minus going to I2 plus 2 electrons. And so this E value ends up being minus 0.54. Because when you switch the direction of the reaction, you change the E0 value from plus to negative. It's the same thing as enthalpy, which is delta H, is that you change from plus or negative when you change the direction of the reaction. So that's what we've done here. We started with iodine, so iodine goes to I2 plus 2 electrons. Now the bromine reaction is written already, but I want you to just notice that the electrons cancel when you add these two different reactions. So Br2 goes to, Br2 plus the 2 electrons goes to 2Br minus. Okay, and this has the plus 1.07. So now what happens is that these two reactions are added to each other. Now notice, I'm not going to write all those electrons again, but notice there's 2 electrons on the left side, there's 2 electrons on the right side. So when I add these equations, I add the columns, the electrons on the left and right cancel. So then you end up with 2I minus plus Br2, and this is the final reaction, which is the sum of the 2 half reactions, makes the final complete reaction. 2 half reactions make a complete reaction. It's logical, right? So, and this makes I2 plus 2 Br minus. Now, do you see the beauty of it? The electrons cancel on both sides, and now we add the E0 values of the 2 half reactions. So what happened in this reaction? What happened is that Br2 was reduced. It gained electrons. What happened to I minus? It was oxidized. It lost electrons. Remember? Leo. Loss, electron, oxidation. I minus is oxidized. Br2 is reduced. We looked at the answer choices. The correct answer is B, 29B. I minus will be oxidized. Any questions? And we see the complete reaction. By the way, during the exam, I would never write the complete reaction. I would just write what I did in the left side. Okay, yeah. I would only write this. Br2 is plus 107. Cl minus is negative. I minus is a smaller negative number. And together, this positive and this negative number makes a positive number, which means spontaneous as written. That's all that would have to happen. Cl minus you would not get a reaction, because Cl minus, starting with Cl minus, creates minus 1.36. And if you have minus 1.36 and plus 1.07, it creates a negative number. Those two reactions would create a negative number, which means it's not spontaneous. So you would not get a spontaneous reaction. It's different if this was an electrolytic cell. Okay, so I'm going a little further here, so it's okay if you don't want to go further. But an electrolytic cell is when you put a battery and you force electrons. Then you can make this reaction occur with Cl minus. But this reaction with Cl minus and Br2, no reaction will occur because it's the value of the E0 is negative with those two reactions, and that means the reaction would not be spontaneous. Yes, so as you said, one thing is oxidized and one thing is reduced. That's very reasonable to put it that way. Because in electrochemistry, the foundation of electrochemistry are these redox reactions. Redox reactions are reduction-oxidation reactions where one chemical or species is reduced and another one is oxidized. And notice the electrons add up here. I mean, at least ACER was friendly enough to make them 2 electrons in each case. They didn't have to do that. They could have made 1, 2 electrons and another 3 electrons. And in those situations, in order to balance, you have to find, just like you find a common denominator in math, you would have to find a common factor. And so the common factor for 2 and 3 would be 6 electrons. So you would have to multiply one equation through by 3 and the other equation through by 2 in order for the electrons to balance and for you to have a balanced reaction at the end. Okay, I think we'll use that up. The only thing I would just mention is that these are standard reduction potentials. You see the little E0 value, superscript 0. And it's because they're in standard conditions, and I think they describe it in the passage anyway. You know, the conditions are 1 mole per liter. Standard pressure. Does anybody know what standard pressure is? So the standard concentration is 1 mole per liter. The standard temperature, standard pressure, do you know what that is? Standard temperature and pressure. Room pressure, yes, that's very safe to say that it's room pressure. Yes, and so that's true. It's room pressure, which is 1 atmospheric pressure. So it's 1 atm, 1 atmospheric pressure. And yes, it's 101.3 kilopascals. And a pascal is the SI unit, and you're expected to know that the pascal is the SI unit for pressure. And so it's 101.3 kilopascals. You're not expected to memorize the number 101.3 at all. But you should know the interconversion of kilopascals and pascals, of course, 1,000. Okay, so that's for question 29. Moving on to question 30, which would reduce a solution of H+. So we're looking at question 30. Which of the following species would reduce a solution of H+ to H2? So reduce, again, reduce is the GERK part. So it's a gain electrons is reduction. So if H plus gains an electron reduction, that means we're talking about an E0 value of 0. So remember, you need to have a positive E0 value for the reaction to occur spontaneously as written. So we already have a gain of electrons. So we need a loss of electrons because these things must be paired. So we need something to be written as an oxidation with the most positive E0 value. If it's written as an oxidation of the most positive E0 value, that means when it's a reduction, it has a negative value. So only one of these chemicals has a negative value written as a reduction in the table, and that's zinc. So zinc has a negative value written as a reduction in table. It means that if you switch it into an oxidation, you turn the equation around so that you can add it to the reduction of hydrogen, and then the electrons cancel, just like I did for iodine and bromine, then yes, you get answer choice C. Okay, so that's how we get question 30 is answer choice C. Okay, questions 31 to 33, some new information is provided about half-reactions, biological systems, and that's another code word of saying time for organic chemistry. So, table 2. So before we answer the question for table 2, perhaps you guys can impress me. Looking at table 2, in the bottom line of the table 2, there's 2 chemicals. And I know we're doing general chemistry right now, but you know, organic chemistry is one of the 4 subjects in section 3, the reactant and the product, at the bottom of table 2. And you said ethanol, but not exactly, because it can't be ethanol, because on means it's a ketone, and a ketone must have R, a ketone must have R, C, double bond, oxygen, and then R on the other side. It's not really drawn nicely. That's not drawn, so I'm not going to write it out. But it's so yes. So let's so not ethanol, cannot be. In fact, there's no ketone possible with 2 carbons. The reactant ethanoate, no, it's not ethanoate. Again, it's the last line. Ethanol is the product. Okay, so CH3CH2OH is ethanol. Eth means there's 2 carbons. All means it's an alcohol. So you can call it ethyl alcohol, but usually, of course, ethanol is the proper name for the product in the final reaction. I'm sure some people might call it Foster's or Guinness, but ethanol is the proper name. But what is the reactant's name? We still haven't gotten it. It's an aldehyde. okay, because it's C double bonded to the oxygen and there's a hydrogen at the end, so that's an aldehyde. So you can call this aldehyde ethanol, F because there's two carbons, of course, so you can call it ethanol with an AL at the end, or acetaldehyde. And you are expected to know both of those names to represent that compound. Okay, so what about what about the third line? Does anyone want to try any guesses at that? Okay, look, organic chemistry. You start with how many carbons do you have? So in the reactant, there's 3 carbons. So we know that it's going to have prop, okay? Because 1 carbon is meth, 2 is F, and 3 is prop, 4 is but, 5 is pent, etc. So this is going to be prop. Now we have a carboxylic acid group at the end. So normally if it's a carboxylic acid, yes, a carboxylate, you end with oic acid, but yes, it's not oic acid because there's no hydrogen attached to it. So it's OH, that's right, so propanoate. So, and then we just have to name that double bond oxygen, it's attached to the second carbon. And so it would be 2-oxy, because it's oxygen, 2-oxypropanoate. 2-oxypropanoate, no problem. The only thing that I would also mention is remind you is that second carbon is also called the alpha carbon in organic chemistry. So it could be alpha or 2-oxypropanoate. And then the other one is even easier because it's just 2-hydroxypropanoate. If it had the hydrogen, it would be 2-hydroxypropanoic acid. Does anybody want to hazard a guess? Now, I know you know the first line is oxygen making water, so I'm not going to ask you that one. But does anybody want to try either of those chemicals in the second line of table 2? How many carbons are in those compounds? And you're right, they're acids missing their hydrogens, so you're going to have some sort of OH kind of ending. There's 4 carbons, which means the prefix is going to be what? It's going to be but, right? 3 is prop, so it's going to be but. And it's going to be, it's going to be OH. So it's going to be, now there's 2 OHs. There's an OH, there's 2 OHs here, right? And there's a double bond between 2 carbons. So it's but, great. Then it's going to be ene. So it's going to be butene because there's a double bond between carbons. And then there's 2 OHs. So that'll be dioate. So butene, butene dioate. There you go, butene dioate. Now, we wouldn't say 208, by the way. It has to be dioate, because 208 would mean that there's an OH group at the second carbon. That's a different meaning. Dioate means that there's 2 OH groups. Okay, so, and then because it's an ene, you should really say if it's trans or cis. Are the groups on the same side of the double bond or opposite sides of the double bond? They're on opposite sides here, it seems. So it would be trans or E. So anyway, that's going a little far. So, okay, so based on table 2, which one of the following is the strongest reducing agent? So there you go. The question is, which is the strongest reducing agent? So now we are going to translate that. Strongest reducing agent means that this is what is going to be oxidized. So I'm looking for something that would be oxidized. So I want to see oxidized, which is a loss of electrons. I want to see something with the most positive value when it loses an electron. Most positive value when it loses an electron. That's what I'm looking for. And when I see the most positive value when losing an electron, that's going to be the strongest reducing agent. So we are looking at question 31, and answer A, when it loses an electron, CH3, CHO, I can't even write it because it doesn't lose an electron. It's written as a gain an electron. So I ignore A. So now I'm going to look at B. When B loses an electron, and I'm looking at B, going to the chart, it's like row. Okay, when it loses an electron, it's the opposite of what I see in table 2. So then for B, the E value would be positive 0.19. That would be the value. Now I'm going to look at C. I look at C, when it loses an electron, its E0 value obviously it's not a high positive value, which would mean spontaneity. So now we're looking at answer choice D, and that's ethanol. So it's the opposite of the reaction that is as written. So the E value would be plus 0.20. So I'm looking for the highest positive value. So between B and D is 0.01 difference higher, and that means that D wins, being the highest positive value oxidation. Okay. So now looking at question 32. So they give you a reaction. For those of you who've done biomedical, can you recognize that equation? What that equation is derived from? What's the name of the parent equation? If you've done biomedical or chemistry, you should know that. Of course, you don't need to know it for the GAMSAT. I'm just playing with you, but it does come up on the exam rather often. And it's a very famous equation used usually for neurons, and but it's also very famous for electrochemistry as we see it here. And it's called the Nernst equation. And they love it on the GAMSAT because they love to see if you know how to deal with logarithms, which is really very, very basic math, but you have to know how to deal with logarithms. Okay, so it tells you that N is the number of moles of electrons, and it gives you the reaction, so great, no problem. So now we're going to calculate KEQ. Okay, so using the equation provided, we have the E0 value of the cell is 1.02. That's the value that we're given for the cell. Now, that's going to be equal to 0.06 divided by N, and N is the number of electrons. So as you see in the chart, the number of electrons is 2. It's clearly 2 in table 2. That's how many electrons are being transferred between one and the other. As I said before, if just one of those was a 3, then when you're comparing a reaction with 3 electrons and the reaction with 2 electrons, you cannot have imbalance. It must be 6 electrons that are being transferred between them. Okay. So anyway, they're dealing with 2. They're being polite, nice. They just want to test you on your logarithm knowledge. So, and that is times log of KEQ. Okay. So now just a little bit of math here. 0.06 divided by 2 is 0.03. So I have 0.03 on the right side of the equation. I'll divide both sides by 0.03. So I end up with 1.02. I got 2 electrons because The question is why 2 electrons? Because the question states that N is the number of moles of electrons transferred in the reaction. So I looked in the table 2 and saw that in all the reactions, it's 2 moles of electrons that are being transferred. 2 E minus. E minus is the symbol for electrons. So I have 1.02 divided by 0.03. And that is the same thing as saying 102 divided by 3, right? You multiply top and bottom by 100. It's just that this is a little easier to imagine because that's just 34. And if you didn't know that was 34, I mean, you could just do it longhand. You just do 102 divided by 3. Or you can guesstimate because you could see the answers are far enough apart. On the exam, often you will guesstimate, no doubt about it. And you'll just say, oh, 102 over 3, that's basically 100 over 3. And 100 over 3, it's easier to imagine that that's 33 and a third. I mean, it's easier to imagine. If it is for you, then great. If not, then just do 102 divided by 3. So anyway, so that's 34. And this is equal to log of k. Now this is a matter of you know it or you don't. I mean, this is a matter, you have to know your rules of logarithms. And the rule of logarithm here is that you can take, you can, just like in math, how you can do the same thing to both sides and it doesn't change the equation. For example, you saw already I divided 3 by 0.03, or I multiplied 3 by 0.03, or divide 3 by 2, or something like that, or add, or whatever. You do something the same on both sides of the equation, you haven't changed the equation. Well, one of the rules of logarithms is that you can raise both sides to the power of 10, or to the power of anything actually. But you can raise both sides to the power of 10. Now, for me to show this to you is not so simple because I can't write it and I am not good at drawing. But it's basically, I'm going to raise both sides to the power of 10, means I'm going to put the number 10 here, 10 here. So I have 10 to the power of 34 is equal to 10 to the power of log k. So 10 to the power of 34 is equal to 10 to the power of log k. So the consequence of this is that we get 10 to the power of 34, which I will use the symbol that way, is equal to k. Then you might say, why did that just happen to me? And it's because both sides are raised to the power of 10 because 10 log base 10 of anything is equal to that anything. In other words, to get rid of the log in front of the k, you have to raise both sides to the power of 10. And then that allows the k to fall down. And trust me, you will use this on the exam. Absolutely, definitely. Not necessarily because of the Nernst equation. Sometimes they'll use it, sometimes they won't. But logarithms come up also in rate law equations in general chemistry, which is not in this particular booklet, but it does come up frequently. And also in physics for decibels, for measuring decibels and sound intensity. There's also a logarithmic equation. So there's logarithmic equations in many areas in the physical sciences, and rest assured, logarithms will be on the exam. And so you have to learn the basic rules. So question 33. So let's look at question 33. So the magnitudes and signs are given. Now look, they give two reactions, and look what's surrounding those E0 values. Those are two parallel lines. Do you see that? You see the E0 value, you see a prime on it, but you see two parallel lines. So that's a mathematical symbol for absolute value, meaning that we do not know if the 0.26 is positive or negative. We do not know if the 0.34 is positive or negative. We just know that the value, the numerical value is 0.26 and 0.34, but we don't know if it's positive or negative. Even if you didn't know that mathematical symbol, it's okay, because it explains it in the passage that we don't know if it's positive or negative. So basically, they're going to give us some clues for us to determine which of these is positive and which of these is negative. If one is positive and one is negative. So when two half cells containing M and N are connected, electrons flow from M to N. Okay, so now we have to figure out, what does it mean that the electrons flow from M to N? If they flow from M, that means M must be losing electrons to N. So M2 minus is going in this direction. M plus 2 electrons. Okay, so it's losing electrons to N. So N is gaining electrons. Now, so we have to think, if N is occurring as written, could N have a negative value? Could N be negative 0.34? Is that a possibility, that N could be negative 0.34? That's right. And there's no way that N could be negative 0.34, because then that reaction could not occur spontaneously as written. The combined reaction would not be able to occur spontaneously as written. So N necessarily must be 0.34, so that when you twist M around in the other direction, it doesn't even matter if M is positive or negative 0.26. Because if you add the two values, you will definitely get an overall positive value. For example, if M was negative 0.26, as long as N is positive 0.34, 0.34 and negative 0.26 makes positive 0.08. So spontaneously as written. Now, if N is positive 0.26, then you get 0.34 plus 0.26, which gives 0.60, positive as written. Either way, if N is positive or negative, as long as N is positive, the reaction will occur spontaneously as written. Okay, great. So, next. When M is connected to a standard hydrogen electrode, so we know that standard hydrogen electrode is 0. That's the potential, and that we can find from the table. So when it's connected to the table with a potential 0, electrons flow from M to S. So from M. So again, M is losing electrons. Only now can I say that M must be positive as written. Because when it's with a cell that has a potential of 0, then M has to be positive, so that M can lose electrons to the standard 0 cell. Now, if they had said the opposite, if they said that M gains electrons from the standard cell, then the E0 value would have to be the opposite. And so yes, M is oxidized when it is in a cell with hydrogen, the standard hydrogen cell. Okay, so then the reduction reaction is with the nitrogen. Sorry, it's not nitrogen, it's just N. So I'm just going to quickly write it plus 2 electrons, and that's going to N2 minus. So and then you just add these two and their cells, and when you add them, you get the final complete reaction, and you get the E0 value of 0.60 volts, which is 0.34 plus 0.26. And that's electrochemistry. And if you've done your review, you can go, this is covered in the Gold Standard book in GAMSAT Chapter 10. It's also, there are some videos that you can get in the lessons section that cover electrochemistry, but there's nothing better than doing practice problems.